Welcome to Value Gene Insight Conversations.
Today, we're doing a deep dive into the food manufacturing sector. We're talking about what we see as probably the biggest blind spot for operational leaders.
And what's that?
It's this quiet, systemic erosion of capacity and, profitability that's driven by these core, ingrained misconceptions about how work should be optimized.
The commercial stakes here are just enormous, aren't they?
Yeah.
Our diagnostics from projects all across North America and Europe, they consistently show the same pattern. We find that the vast majority of food plants are leaving, a tremendous amount of potential on the table, somewhere between 15 and 30% of their capacity, their quality, their profit margin. It's just not being captured.
And that 15 to 30%, it isn't lost because of, macroeconomic trends or needing a massive capital project.
It's not about ripping out a whole production line.
Exactly. It's fundamentally about how work is designed and executed, or maybe more accurately, how it's misexecuted. So our mission today is to walk through the 6 most common false beliefs that we run into on the factory floor.
Beliefs that directly hurt stability and just lock businesses into this high-cost holding pattern.
That's it.
Okay, let's unpack this. Before we get into what's broken, maybe we should establish the foundation. For a plant to go from just average to, say, world-class performance, what are those key disciplines that make the difference?
It really comes down to the rigor or, the lack of it in 3 specific areas. First is what we call engineered work.
Okay.
This is about moving past just how we've always done it. It's about deliberately designing every single critical task, a changeover, a wash cycle, a daily routine, to be efficient, ergonomic, and error-resistant.
The goal being to make the right way the easiest way.
Precisely. When we engineer the work with that level of rigor, we're slashing the physical load, we're minimizing the cognitive demand, and we're building mistake-proofing right into the process itself. That's how you eliminate variability.
But that design, no matter how brilliant, is useless if it just sits in a binder, right? That brings us to the second discipline, what you call the human bridge. How do you make sure those steps actually happen on the floor?
Yeah, that's the critical link. The barrier is almost always what we term knowledge flow and execution fidelity.
So it's more than just having an SOP.
Much more. A document on a server does nothing. The standards have to be visual, they have to be concise, accessible, right there at the point of use. And critically, the teams have to understand the why.
That is such a key distinction. When we do audits, we often see operators just following a step, a rote procedure, but they have no idea what happens if they skip it.
Exactly. And execution only becomes truly reliable when that operator understands the commercial risk, the safety risk of every step. When the standard actually makes their job easier and safer, that's the tipping point.
It stops being a management rule and becomes something the team itself defends.
Yes. And then you close the loop with a third discipline, performance visibility and refinement. This is the feedback system.
Okay.
It ensures those standards don't just, drift over time. We're talking about real-time data captured at the point of work and reviewed frequently, shift by shift even. This lets you make rapid adjustments as conditions change.
When you get those 3 in balance, the engineered work, the knowledge flow, and the visibility, the results are pretty predictable.
Highly predictable. We routinely see changeovers cut in half, off-spec waste drops 20 to 35%, unplanned downtime, that falls by 25, even 40%. The plant just becomes stable.
Now we can see how quickly those disciplines get undermined. Let's start with a big one. A myth that hits capacity and human capital right where it hurts. This is misconception number 1. Filling every second boosts productivity.
This is probably the most common trap, especially in CPG. A manager sees an operator pause for a moment, maybe checking a screen, and their first instinct is wasted time.
So they pile on more tasks to maximize that person's time.
Right. But the flaw is that this completely ignores the real physical and cognitive limits of human performance. Instead of getting more output, you just create a fragile system that's prone to burnout.
And we've quantified the physical side of this. Think about a confectionery line. We've seen operations where a packer is expected to squat and lift over 1,500 times in a single shift. That's 3 times a minute.
It's completely unsustainable. Or on a produce line, manual lifting that adds up to tens of thousands of pounds per person, per shift. That's not just an injury risk. It's a guarantee that throughput will drop as fatigue builds.
And the cognitive side is just as damaging, even if it's less visible.
A dairy operator trying to monitor too many temperature zones, manage multiple SKUs, and run quality checks all at once. They're focus fractures. That's when you get huge errors, like a missed spoilage risk that could cost a fortune.
So for a plant manager listening, what's the takeaway? How do you fight that urge to fill every second?
You have to shift your focus from activity to flow. True optimization means building recovery into the rhythm of the work. Our research shows you have to limit the simultaneous decisions for any given role to 3 or fewer.
And when you do that,
When you bring in that intentional pacing, we see error rates drop by up to 30%. It's counterintuitive, but slowing down to create focus actually speeds up reliable output.
this idea of fatigue and system design connects right into another one. Misconception number 5. Employees just don't care enough. We need stricter discipline.
Yes. When output is shaky, management often defaults to blaming the workers. It's a behavioral problem, they say. It's about motivation, but it's so destructive.
I agree. The assumption is that the worker is the problem, but we almost always find the system is the real culprit.
Exactly. That operator skipping a sanitation check. Maybe it's not because they're lazy. Maybe it's because the protocol is a 12-step nightmare that's impossible to follow mid-shift.
Or the performance fault, the quality issue, is because the task itself exceeds ergonomic limits. Like repeated overhead reaches with 50-pound bags. The worker is just physically unable to maintain the correct method shift after shift.
And that blame game, it just tanks morale. So we draw on industrial psychology here. The answer isn't punishment. It's shifting from blaming the worker to fixing the system design.
Involving them in the process.
Absolutely. Explain the why, get the teams involved in refining the workflow, give them ownership. In plants where we've done this, we've seen deviations drop by a quarter. It proves that most problems are in the system, not the person.
Okay, so if the system is often failing the workers, that failure usually starts with the documentation. That brings us to our second discipline, knowledge flow. Let's look at misconception number 2. Procedures guarantee performance.
This is a lethal assumption, especially in food safety. It's confusing the existence of a document with actual process control. We find SOPs that are just riddled with vague language.
Like what? What's an example?
An instruction on a nut processing line that just says, sanitize equipment as needed.
Which means something different to every person on every shift.
Exactly. The risk of major allergen contamination there is huge. Or a changeover guide that's so confusing a new operator has to stop production and wait hours just for someone to explain it.
And there's another gap in this misconception, isn't there?
Yes. Procedures almost always say what to do, but they almost never say how long it should take. Without a time target, efficiency is just a guess. We've seen packing times vary by 35% because there was no benchmark. We saw a changeover that everyone assumed took 2 hours.
And in reality,
After we engineered the work, it was an 18-minute task. 18.
so the procedure has to be a true performance tool. It needs time benchmarks. It needs to be visual for the operator, maybe even a video for training.
Which leads right into the next problem, which is atrophy. Misconception number 3. Our work instructions from 3 years ago are still adequate.
Oh, this is a big one. Management just underestimates how quickly things change. A recipe gets tweaked, a piece of equipment is upgraded.
But the SOP from 2021 is still taxed to the wall. This creates a dangerous gap between the written standard and what's actually happening, forcing people to improvise. And improvisation is the enemy of stability.
We saw that at a processing plant, didn't we? A decade-old mixing instruction that just said, blend to required consistency.
That's right. It worked sort of until they retrofitted the equipment and changed the agitator speeds. Suddenly that instruction was meaningless and batch quality was all over the place.
The manual update process is the bottleneck.
It is. The solution isn't just an annual review, it's what we call continuous regeneration. This is where digital platforms come in. We use software that can analyze the current workflow and then auto-regenerate the instructions with new visuals, new time benchmarks, in as little as 15 minutes.
Now hold on. AI regenerating complex SOPs in 15 minutes. That might sound like science fiction or a huge capital project to an executive listening.
That's a fair challenge. It's not about magic AI replacing people. It's about digitizing the inputs. We're talking about platforms where a subject matter expert makes one change, say a mixing temperature, and the system automatically updates the training video, the supervisor checklist, the operator's visual guide, and recalculates the timing.
So it just dramatically speeds up the human review and deployment cycle.
It makes that 15-minute update achievable for critical steps.
That focus on digital platforms is a perfect transition. Let's talk about misconception number 4. Digital tools are too hard to implement and won't integrate with legacy systems.
This is a major blocker at the executive level. They see digital and they think of a massive, costly rip-and-replace project that's going to clash with their 20-year-old PLCs.
We push back on that constantly.
We have to. Digital adoption should start with targeted low-cost pilots. You validate the ROI immediately. For those SOPs we just talked about, you don't need a new network. A few rugged tablets, which cost a few $100s each, connect over existing Wi-Fi.
And the ROI is incredibly fast. We've seen those pilots deliver 25% quicker changeovers within weeks just because the steps are visual and interactive.
And the same thing applies to data collection. You don't need a huge sensor array. Start with 3 or 4 high-value variables: line speed, temperature, yield.
And the sensors themselves are not that expensive.
No. Affordable, off-the-shelf sensors, often less than $500 total, can plug right into existing PLCs. You're not replacing the control system, you're just tapping into it.
Can you give an example? What's something a simple system like that might uncover?
Absolutely. In one pilot, just adding time and temperature sensors revealed a 40% variance in mixing and cooling times for a sauce. 40%. It was completely invisible to manual tracking.
We thought they were consistent.
They did, but by digitizing those guidelines and adding a few simple sensors, that plant saw its onboarding time for new hires fall by 60% and errors dropped by 22%. You scale it gradually.
Okay, finally, let's address the ultimate failure of rigor. Misconception number 6. Downtime is inevitable. This is just operational resignation.
It is. It's this passive acceptance that every unplanned stop is just bad luck, a mechanical failure, a human slip-up. It ignores the fact that most downtime comes from preventable, repeatable root causes.
We see this all the time in our analysis. A changeover delay gets blamed on the operator, but the root cause was the unclear procedure we talked about earlier.
Or a big conveyor incident looks like a machine failure, but you trace it back and find it was caused by improper storage of parts during a rushed cleanup. That's a system failure, not a mechanical one.
It's a systemic issue pretending to be a random event.
And the only way to fix it is with proactive rigor. Downtime is not destiny. It's a solvable problem. We use root cause analysis to find the real patterns. For example, in one project, we simply worked with supervisors to identify who had critical skills, like changeover expertise.
And then just rearrange the schedule to make sure they had coverage on all shifts.
That's it. A simple, no-cost intervention. And unplanned stops decreased by 30% in one quarter.
So when you pull all 6 of these misconceptions together, from pushing people too hard to failing to update standards to just accepting downtime, they all point back to the same fundamental truth. The most resilient manufacturing operations, they're not the ones with the newest equipment. They're the ones that manage that human bridge between process design and execution with the highest possible fidelity. So the question for everyone listening should be, are we truly managing our processes, or are we just documenting our problems?
Thank you for listening to Value Gene Insight Conversations. To deep dive, please see the show notes. For more on food industry topics, visit valuegeneconsulting.com or subscribe wherever you get your podcasts. If today's discussion resonated with you, please do not hesitate to reach out to us to continue this dialogue.